So, students, now let us talk of phasor notation. I will write in the note. I will write network theory terminology. Network theory means electrical circuits and networks. Given V of t, that means voltage is a function of time. Then how to get V of s? V suffix s, that means steady state voltage equation. So, given V of t, then if we suppress means remove, suppress means remove, then if we suppress real part, Re means real part, comma e power j omega t, then we get steady state it is also called as a frequency domain or otherwise phasor domain. Equation called V suffix s. So given V of t, then if we suppress, that means remove real part Re, comma e power j omega t, then we get a steady state or otherwise frequency domain or otherwise phasor domain equation called V of s. So I will take one example, you will understand. Example, V of t is equal to 5 into cos of omega t plus 60 degrees. This is a time domain voltage equation. Now find phasor domain equation. So this is the question. Now we will write answer here. Before that, I will do one thing. For example, you take network theory, V of t is equal to 5 cos omega t plus 60 degrees is applied to this network. Let us say 10 ohms is there, and here 100 picofarad is there. Now 10 millihenry is there. Now actually this voltage is a function of time. So here this voltage is a function of time. Then this is resistance. This is capacitance. This is actually inductance. This one is resistor actually. So here in this circuit current is generated. That current is also function of time actually. So this is called time domain. Okay. So this is called time domain, dear friends. If voltage is applied in time domain, then current is also in time domain. So here resistance parameter, capacitance parameter, inductance parameter are there. Now whenever we write this in steady state domain, if you write unknowingly, you will be writing without observation. आप लोग बिना observation करके फटाफट लिखता होगा. अभी थोड़ा सा observe करिए. Now observe students. So here you write like this. This is written as V suffix s is equal to 5 at an angle of e power j60 you will write, or otherwise you will be writing like this, 5 at an angle of 60 you will be writing. This is called phasor domain equation. Now you will write this as it is, R is equal to 10 ohms only. Now here you will be writing this as a 1 by j omega c ohms. Now it is in a capacitor element form, but it has become impedance form now. And similarly, this becomes j omega L, and this also has become impedance form, but it was in inductor form actually. Now here this current becomes steady state form, I suffix s you will write. So dear student, this is called frequency domain, because here omega is 2 pi f, that is why it is called frequency domain. That is one name. Second name is phasor domain, because for example if you see this, let us say j omega L, it is imaginary quantity. This imaginary quantity can be written in phasor form. For example, a plus jb is equal to magnitude is a square plus b square e power j tan inverse of b by a. This is magnitude. And phase, this is called phasor. Phasor means quantity having magnitude and phase, like complex numbers. They are phasors. But here there is no complex number. 10, 100, 10, they are not complex numbers. So once if you go to the frequency domain, and automatically these quantities become phasors. That means they have phase and magnitude. That is why it is also called as phasor domain. First name is, omega is there. Omega means 2 pi f. It is called as frequency domain. This is also called as a steady state domain. What is the reason? For example, if capacitor is there, now impedance of the capacitor, impedance of the capacitor is equal to 1 by SC, where this is Laplace domain. Okay, for steady state, where S is actually, where S is sigma plus j omega in Laplace domain, so it is called complex frequency. Now for steady state, for steady state, S becomes j omega. Now you substitute S is equal to j omega, you get 1 by j omega c. That means here you have written j omega in place of Laplace variable s. In place of s you have substituted j omega. That means s is equal to j omega is substituted for steady state only. So that is why this is also called as steady state domain. So it has three names now: steady state domain, or otherwise frequency domain, or otherwise phasor domain. So dear students, that is what I wrote here. Given time domain voltage, then if we suppress Re, that means real part, comma e power j omega t, then we get steady state, or otherwise frequency domain, or otherwise phasor domain equation called V suffix s. So here I am telling you one thing, that if V of t means time domain, V of s means it is Laplace domain, and V suffix s means it is steady state domain. So these are the variables we use. Okay. So here V suffix s we are using. We are not using V of s. V of s means Laplace domain, students. And in the Laplace domain, if we put if s is equal to j omega, s is equal to j omega, then you get V of j omega. Now it becomes a complex number. Now this is also called as phasor. Omega is equal to 2 pi f, frequency is the frequency domain. This itself is written as V suffix s. So V suffix s means steady state, or otherwise frequency domain, or otherwise phasor domain. This is a network theory. Now once again let us go there. Now what statement is written here? How will you write this equation in this way? Okay, now let us see that. You take this equation v of t is equal to 5. This cos is written as real part of e power j omega t plus 60. Now that is equal to 5 real part e power j omega t e power j60. This is v of t. Suppress means remove. Suppress re, that means this one, comma e power j omega t, that means this one. You have to remove them. Then we get v suffix s, that means phasor form. So vs is equal to 5 at an angle of 5 e power j60, that is also written like this, 5 at an angle of 60. Okay, so this statement you have to remember, student. Now in place of v of t, if electric field comes, then same procedure we will get e suffix s we will get. Now for example, student, here sine is there, na sine. Then what you do, convert that to cos. Then again same procedure. That means here we are taking cos omega t as a reference. Here also in entire circuit, in the steady state, in entire circuit, voltages and currents are in terms of cos omega t, then only magnitude and phase will be changing in every component. So here currents and voltages in this circuit in steady state will be function of cos omega t, but phase will be changing and magnitude will be changing. So that is why phase and magnitude changes. That is why we talk only in terms of phase and magnitude changes. That is called phasor. Phasor means magnitude and phase. So this point you have to remember, students. How you get phasor form. Okay, given v of t, then if we suppress means remove re comma e power j omega t, then we get steady state or frequency domain or phasor domain equation called vs. I told you so many times because this is very very important, student, in our subject. Okay, now what is opposite? For example, given this, how to get this back? You have to do opposite process. Whatever you left, then again take them back. जिसको छोड़ दिया उसको वापस लेना है. आप लोग आर ई को छोड़ दिया, फिर आर ई को वापस लेना है. ई पावर जे ओमेगा टी को छोड़ दिया, फिर ई पावर जे ओमेगा टी से मल्टीप्लाई करना है आप लोग. So I am writing one statement here like this. That statement is, given steady state equation vs, okay, given steady state equation vs, then multiply with e power j omega t and take re, then we get time domain equation v of t. This you have to remember. Example, given vs is equal to 5 at an angle of 60, then find v of t. I told you The equation is, I will put that in the box. Vs is given. Then multiply with, it is written, multiply with e power j omega t. Then take Re, that means real part. Then you get V of t. So this is statement form I wrote. This is a mathematical form. Given phasor equation, then multiply with e power j omega t, and after that take Re, you get a time domain equation. So let us apply this here. V of t is equal to Re. Vs is 5 at an angle of e power j60. This is e power j omega t. So this is Re 5 e power j omega t plus 60. So that means what is real part of this 5 cos of omega t plus 60 degrees. So this is the answer. So I spoke in terms of voltages, that is network theory. But in electromagnetic theory, in network theory, voltage means in electromagnetic theory we get electric field. Electric field unit is volt per meter. In network theory, current, the unit is ampere. But in electromagnetic theory, that is h bar, magnetic field intensity, that is ampere per meter. So if electric field is in time domain, then how to convert that to phasor domain? Suppress Re, comma e power j omega t. If electric field is in phasor domain, then how to get time domain? Multiply phasor domain electric field equation with e power j omega t and then take Re, then we get a time domain electric field equation. Okay. Now, third point I want to write, dear students. Third point. D by dt in time domain, d by dt in time domain is replaced with j omega in phasor domain. Okay. So here d by dt is there, then it is replaced with phasor domain. Example I will tell. For example, x of t Laplace transform is x of s. Then d by dt of x of t Laplace transform is s into x of s minus small x of 0. Of course, in steady state that is not taken. Now, d by dt x of t in steady state domain, s is equal to j omega is replaced. So in place of s you get j omega. So x of j omega. Now if you see here carefully, in time domain d by dt is there, and here it is changed as j omega. That is what written. D by dt in time domain is replaced with j omega in phasor domain or otherwise steady state domain. So these 3 points are important. Now I am writing the equations here. I will write time domain equations. Then using these statements I will write in terms of course we will be using only this one. So here time domain equation, and first one is del cross E is equal to minus mu into dou h bar by dou t, and in phasor form or otherwise you say frequency domain frequency domain. Now here del is dou by dou x ax plus dou by dou y ay plus dou by dou z az. It is not a function of time, so no need to suppress time and all. So it is written as it is, del bar. Now electric field is a function of x comma y comma z comma t, and it is in time domain. If we suppress time, then it is written es, then it will be a function of x comma y comma z only. Time will not be there, so it is written as es bar. So wherever time is there, na, for example voltage v of t is there, then here v suffix s is written. Okay, so now minus mu is not a function of time. Then I told you d by dt in time domain is replaced with j omega in the phasor domain. Now h bar is a function of time, so it is written as hs. Now del cross E bar is equal to minus of j omega mu hs bar. This is the equation, this equation time domain, this equation in phasor domain, students. Anyway, no need to remember. If you know that, then simply you can write this by putting d by dt j omega, and h is written as h of t will be there here. Here hs, e of t will be there. Here you will write es. Now second Maxwell equation, del cross h is equal to sigma e plus epsilon dou e by dou t in time domain, and in frequency domain you will write del cross hs bar is equal to sigma es bar plus, here d by dt is written as j omega, so j omega epsilon e s bar it is written, so sigma plus j omega epsilon e s bar, so del cross hs. This is the equation. Okay, now third equation for our case, special case called homogeneous medium, linear medium, isotropic and charge free medium. For that divergence of E is equal to 0. So if you write this in phasor domain, del dot es is equal to 0. Similarly, fourth equation was divergence of h bar is equal to 0 in phasor domain, del bar dot hs bar is equal to 0. Now electric wave equation was del square E bar is equal to mu sigma dou E bar by dou t plus mu epsilon dou square E bar divided by dou square. It was in time domain. Now let us write that in phasor domain, del square. Here E of t, it is in time domain. We will write it as a Es. Then mu sigma d by dt is written as j omega and Es bar plus mu epsilon. So dou by dou t is j omega, dou square by dou t square means j omega whole square, j omega whole square, then E bar is there, Es. Now del square Es bar is equal to j omega mu. J omega mu is common, then what remains is here sigma plus j omega 1 mu, then 1 j omega and epsilon is remaining, so j omega epsilon is remaining, then es bar is common here. So dear students, this E means electric field, this E means electric field, del is 1 by meter, del square means 1 by meter square, so this should have unit of 1 by meter square, that for any medium at particular frequency, for example you are sending radio mirchi signal 98.3 megahertz, then omega is constant, then for particular medium, air medium for example, mu is constant, sigma almost 0, epsilon is also constant, so this is constant and units are 1 by meter square. Once again I am telling, the electric field unit, here electric field unit is same. Del unit is 1 by meter. Del square means 1 by meter square. So this unit is 1 by meter square. That is given new name called gamma square. Gamma square. In Greek, now this is small gamma, this is capital gamma. So this small gamma is taken as a symbol for propagation constant. This capital gamma is taken as a symbol for reflection coefficient. So this is called as gamma square. Now del square ES bar is equal to gamma square ES bar. I will be writing this separately, this gamma square. So this is the equation. It has become very simple, you see. Now here time was there, here time is suppressed. Again, if you want time, you can convert it back from phasor domain to uh, time domain. Actually, ES is there means it is in steady state domain. Here time terms are not seen. But again, if you convert into time domain, then again you will see time terms. What is the advantage of this? Here differentiation with respect to time, dou by dou t, dou by dou t, dou square by dou t square was there. Now simply they have become algebraic terms here. Now similar to this, there was one more equation. If you see carefully, I will write that side. So in time domain, del square h bar is equal to mu sigma dou h bar by dou t mu epsilon dou square h bar divided by dou t square. This was in time domain. Now in frequency domain, this becomes actually del square hs bar is equal to mu sigma j omega into hs bar plus mu epsilon j omega whole square hs bar. Once again it becomes similar to the previous one only. So j omega mu common sigma plus j omega epsilon hs bar. So this is written as gamma square hs bar del square hs bar. No need to do this because already we have done for electric field. Exactly similar equation comes here. So my dear students, here what is gamma square, and we will talk of that one. So dear students, this was the equation del square Es bar is equal to j omega mu sigma plus j omega epsilon Es bar, and it is named as gamma square. So Es bar del square Es bar, where gamma square is equal to j omega mu sigma plus j omega epsilon. I told you the unit is 1 by meter square. Because Es same unit, del unit is 1 by meter, so del square unit and gamma square units are same. So dear students, you remember this, we are studying uniform plane waves. In uniform plane waves, electromagnetic wave carries energy or otherwise power from one location to other location. Same thing happens in transmission line also, in waveguide also. So that is why you have to listen this chapter carefully, and if you understand this chapter, almost EM theory will be over because same thing repeats. So that is why you observe everything very carefully. And also one more thing, students, derivations are not useful in electromagnetic theory. You have to remember the formulas and you must know how to use those formulas in solving questions. Then you can solve all the questions in examination. डेरिवेशंस का ज़रूरत नहीं है, फार्मूलास याद रखना है और वो फार्मूलास को कैसे यूज़ करना है क्वेश्चन सॉल्व करने में वो देखना है, वो पूरा क्वेश्चन सॉल्व हो जाता है. बट लेकिन हम डेरिवेशंस क्यों कर रहा है, आपको डेरिवेशंस करने का समय में फार्मूलास याद हो जाएगा, आपको थोड़ा कॉन्सेप्ट भी पता चल जाएगा. सो इसलिए मैं बोल रहा हूँ अभी शुरू में इधर इस चैप्टर शुरू में ही बोल रहा हूँ, डेरिवेशंस कैसे करना है उसको ध्यान मत दे दीजिए आप लोग. फार्मूला जो आएगा, कौन सा फार्मूला याद करना है, उसको याद रखना है आप लोग. सो डियर स्टूडेंट्स, आई एम डूइंग डेरिवेशंस and you need not to learn the derivation, and whatever formula you get, you have to remember that one. Okay, so this is gamma square. Now if you write gamma, that is j omega mu into sigma plus j omega epsilon under root, and root of 1 by meter square is 1 by meter. This you have to remember. That means in transmission line chapter also gamma comes. In the rectangular waveguide chapter also gamma comes. So the structure of discussion is same for all the chapters. So that is why you listen this chapter carefully. Now mathematics. J omega mu, it is imaginary number. This is sigma plus j omega epsilon. It is a complex number. Complex number multiplied with imaginary number gives complex number. Root of complex number is complex number again. Every complex number has real part and imaginary part. So this has gamma is actually complex. So this gamma is a complex number that has a real part and imaginary part. So this gamma is a complex number. Now real part is named as alpha and imaginary part is named as beta. Alpha plus j beta. So this is the general structure of the gamma. Now here, if let us say this is equation number 1, this is equation number 2, this is equation number 3. Put equation 3 in equation number 1 here. So gamma is equal to alpha plus j beta. So alpha plus j beta whole square is equal to this one, j omega mu sigma plus j omega epsilon. Now this becomes alpha square plus j beta square. That means j square is minus 1. So minus beta square. Then j 2 alpha beta, this one, is equal to here j into j square. J square is minus 1. Omega into omega, omega square. So minus omega square mu epsilon. Here mu is there, epsilon is there. Then plus j omega mu sigma. Now compare real, both sides. This is real and here this is real. If you compare both sides real terms, so one equation is alpha square minus beta square is equal to minus omega square mu epsilon. So let us say this is equation number 4, dear students. You take mod of equation 1, take modulus of equation 1 both sides. So here gamma is written as alpha plus j beta. So mod of that whole square is equal to, if you take modulus to this one, for this modulus you have to take, so j omega mu modulus and sigma plus j omega epsilon modulus you have to take. Now root of this, what is the modulus of this? Root of alpha square plus beta square, and again whole square is there. So modulus of this alpha plus j beta is this one, whole square is there, and modulus of this one is root of omega mu whole square, that becomes omega mu. For this root of sigma square omega epsilon whole square. Now here alpha square plus beta square is equal to, here dear students, omega epsilon whole square you pull out, then it becomes omega mu into omega epsilon plus root of sigma by omega epsilon whole square plus 1 it becomes. Now this equation is alpha square plus beta square, that is equal to omega square mu epsilon root of 1 plus sigma by omega epsilon whole square. So this is equation number, let us say 5. Now I am rewriting this equation here, equation 4. You send this minus here, then minus alpha square plus beta square is equal to omega square mu epsilon. So this is equation number 6 I am writing. So this is equation number 4 only. So equation 4 implies I am sending minus of this side, and if you add both of them, this equation 5 and 6, so equation 5 plus equation 6, if you add them, alpha square minus alpha square gone, 2 beta square. Now omega square mu epsilon common, so omega square mu epsilon, then this plus this one, that means root of 1 plus sigma by omega whole square plus 1. Now you send this 2 here, so then beta is equal to omega, root of you have to take, omega square root is omega, then mu epsilon by 2, that comes under root, so mu epsilon divided by 2, then for this also root comes, so 1 plus sigma by omega epsilon whole square plus 1. Okay dear students, so this is beta equation, and in this beta equation this is omega root mu epsilon by 2, and here inside this root of 1 plus sigma by omega epsilon whole square plus 1 is there, up to this root is there, but for this 1 there is no root. Similarly, if you do the calculation, then alpha becomes same equation, but here minus 1 comes actually. So this is a beta equation. Now similarly, you subtract them. If you subtract them, equation 5 minus of equation 6. So minus of means here plus comes, then here minus comes, here minus comes. Then 2 alpha square, it becomes a 2 alpha square, that is equal to omega square mu epsilon and root of 1 plus sigma by omega whole square minus 1, dear students. Now if you take alpha here, omega square root is omega, then root of mu epsilon divided by 2 and root of 1 plus sigma by omega epsilon whole square minus 1. Okay, so this is alpha. Now I am writing the units here. Later on I will explain you. The unit of beta is radian per meter. This is Nepper per meter. I will explain this later on. It is written like this: NP per meter. Nepper per meter. Short name of Nepper is NP. So this is alpha equation. Now, dear students, to solve some particular type of questions, you have to remember alpha beta equation. Otherwise, for all the cases, no need to remember alpha and beta equation. Why? Why? I will tell you. For example, gamma is equal to j omega mu sigma plus j omega. You have to remember. So let us say omega is 10 power 6 given in any question. Then mu r is equal to 2. Then sigma is equal to 10 to the power 10. It is given. So let us say then epsilon is equal to 5. It is given. What you do? No need to apply, no need to substitute in these equations. Simply here j omega is 10 power 6, mu is mu naught 4 pi into 10 to the power minus 7, mu naught into mu r is 2 plus sigma is 10 plus j omega is 10 power 6, epsilon naught into epsilon r, this is 1 by 36 pi 10 to the power minus 9 and epsilon r is 5. So like this, in the calculator this becomes complex number. Root of complex number if you put, then automatically let us assume that I am not calculating exact value. Let us assume that this is 3 plus j5. मान लीजिए ऐसा आया है, मान लीजिए ये नहीं है आंसर इसका, ऐसा आया है मान लीजिए. Now this is called alpha, this is called beta. So no need to substitute in these formulas. Even if you substitute in these formulas, you get same answer. So dear students, you have to remember them to solve particular questions. In workbook questions are there, we will solve, but for all cases no need to remember them anyway. So you try to remember that. Okay. Now here I am writing the names. Later on I will explain. Gamma is called as a propagation constant, that is 1 by meter, and alpha is called attenuation constant. Attenuation means decrease. We will discuss that. So Nepper per meter. Beta is called phase shift constant. Phase shift constant, that is radian per meter. You have to remember these names also. We will discuss that later on. Now, once if you talk of gamma and then alpha and then beta, we have to talk of solution of the wave equation. So now here I am putting the heading solution of electric wave equation in phasor domain. In phasor domain. So the equation is del square Es bar is equal to gamma square Es bar. So let us say this is equation number 1. We will be solving in phasor domain. Then once if we get the answer, then we can convert that to time domain. Because solving the equations in phasor domain is very easy. That is why here every time we solve the equation in phasor domain, if we want to do any derivation, we will do the derivation in the phasor domain, then we can convert that to time domain. Okay. Now, in rectangular coordinate system, equation 1 is del square means dou square by dou x square, dou square by dou y square, dou square by dou z square. So now it becomes dou square es bar divided by dou x square, dou square es bar by dou y square, dou square es bar divided by dou z square is equal to gamma square es bar. So this is equation number 2. Now, dear students, for example, this is x direction. If I am moving in x direction, then I am carrying this pen, I am carrying this duster. They also move in x direction. For example, I am moving in x direction, but this pen is in z direction. Okay, this duster is in y direction, like this. Okay, this duster is in y direction. This pen is in z direction. This is in y direction. This is x direction, this is y direction, this is z direction. If I move in x direction like this, then this pen is in z direction, but this duster is looking in y direction. This pen is looking in z direction, but I am carrying them. And if I move in x direction, then this pen and this duster, they also move in x direction because I am carrying them. So even though the face इसका शक्ल है पेन का, the face of this is in z direction, the face of this is in y direction, but I am carrying them. If I move in x direction, then they are also functions of x only. For example, if I move in y direction like this, then they are also functions of y only. For example, if I move in z direction, then they are also functions of z only. If I move in x comma y comma z direction diagonally, they are also functions of x comma y comma z only. So in this way, if electromagnetic wave moves in z direction, then that electromagnetic wave carries electric field and magnetic field. They are also functions of z only. In the textbooks, they write, let us assume that electromagnetic wave is traveling in z direction. Then electric field and magnetic field are functions of z only. Why they assume that electromagnetic wave is traveling in z direction in the textbooks? For understanding purpose, students can easily understand if wave travels in one direction, then they can write the equations for other directions very easily. Okay, so let that wave is traveling in z direction. So dear students, let the electromagnetic wave is traveling in z direction. Then both E bar, that means E bar equation is actually E bar is equal to electric field can have x component and it can have y component, it can have z component, it can have any component. Both E bar and H bar, once again H bar can have x component or otherwise y component or otherwise z component. It can have any component, x component, y component, z component. So both E bar comma H bar are functions of z only. I told no, you will confuse here. Sir, e suffix x is there, e suffix y is there, e suffix z is there. I am telling you, assume that this is electric field. Electric field can have x direction also, y direction also, z direction also. But if wave is traveling in z direction, then they are functions of z only. So direction can be any direction. For example, I will explain you, student. Now you see this one. This one. This is assume that this is electric field. It is in x direction. Now if wave moves in z direction, then this electric field is in x direction only, but it will be a function of z because upwards. So if electric field has y component, direction is y only, but if wave is moving in z direction, then this will be a function of z only, like this. Now this is electric field, you assume it is in z direction. If wave moves in z direction, then electric field will be a function of direction of electric field is z, but it will be a function of z only. Once again I am telling. For example, assume this is electric field. If this electric field direction is x, then you say electric field x component is present. Then for wave traveling in z direction, this will be moving in z direction, so that is a function of z only. But direction is x only. So if wave traveling, if electric field is in y direction, then if wave traveling in z direction, this electric field y direction component is a function of z only. So if electric field is in z direction, this is called electric field z component. Then for wave traveling in z direction, this will be moving in z direction only. So electric field and magnetic field can have any direction. That means they can have any component, but they are functions of z only. Example I will write. So electric field x component is E naught cos of omega t minus bz, like this. So even though direction is x direction, but it is a function of z. Similarly, electric field y component also can have E naught cos of omega t minus beta z, like this. So it is y component, but it is a function of z only. So this type of equations we will get after derivation. So don't confuse. E suffix x is there means it does not mean inside this x will be there. ये ऐसा नहीं है. E suffix x लिखा हुआ है मतलब ये है इलेक्ट्रिक फील्ड x कंपोनेंट, मतलब ये नहीं है इसके अंदर x रहता है करके मीनिंग नहीं है उसका. उसका डायरेक्शन x डायरेक्शन है इलेक्ट्रिक फील्ड x कंपोनेंट का, बट उसके अंदर x भी हो सकता है, y भी हो सकता है, z भी हो सकता है. बट फॉर वेव ट्रैवलिंग इन z डायरेक्शन सिर्फ z रहता है बस, और कुछ नहीं रहता. फॉर वेव ट्रैवलिंग इन x डायरेक्शन इधर x रहता है. फॉर वेव ट्रैवलिंग इन y डायरेक्शन इधर y रहता है. फॉर वेव ट्रैवलिंग इन x कामा y कामा z डायरेक्शन ऐसा रहता है cos ऑफ ओमेगा t माइनस बेटा x माइनस बेटा y, सो माइनस बेटा z ऐसा रहता है. फॉर वेव ट्रैवलिंग इन x y z डायरेक्शन ऐसा रहता है. So my dear students, why I am spending so much time here, you should not confuse. So if wave travels in x comma y comma z direction, x comma y comma z direction means like this. This is x axis, this is y axis, this is z axis. If wave travels like this, that is x direction. Wave travels like this, that is y direction. Wave travels like this, that is z direction. If wave travels like this, that is called the wave is traveling in x comma y comma z direction. In that case, electric field and magnetic field are functions of x comma y comma z, like this. So if wave travels only z direction, then electric field x component, y component, z component, magnetic field x component, magnetic field y component, magnetic field z component, all will be functions of z only. Why they take in textbooks wave traveling in z direction? I told you equation will be simple, students can easily understand, then they can extend that knowledge for complicated cases also. So that is why in the textbooks, in a uniform plane wave chapter also, they assume that wave is traveling in z direction. In transmission line chapter also they assume that wave is traveling in z direction. In the waveguide chapter also they will assume that wave is traveling in z direction. So that you understand uniform plane wave properly, then transmission line and waveguides also become very simple. So dear students, now here let the EM wave is traveling in z direction, then both the electric field and magnetic field are functions of z only. So if electric field is a function of z, then dou by dou x partial differentiation with x becomes 0. Similarly, if electric field is a function of z only, then dou by dou y also become 0. Then this only present. Then z only. Then equation 2 becomes, then equation 2 becomes dou square, I will write here 0 plus 0 plus dou square ES bar divided by dou z square is equal to gamma square ES bar. So like this it becomes. Now here electric field equation is having all the components. So in general E bar ES bar is equal to, it is having a x component and then y component and then z component. This is electric field. In steady state means this also in steady state, this also in steady state, z component is also in steady state. So in general ES bar has x, y, z components. Okay. Now let us say this is equation number 3 and this is equation number 4. Okay dear students. Now put 4 in 3. Now dou square y dou z square of this one is nothing but exs ax cap eys ay cap ezs az cap, that is equal to gamma square into exs ax cap eys ay cap ezs az cap. Student, Ex means electric field x component. Of course, it will be in time domain. Exs means electric field x component in phasor domain. That is the meaning. Okay. Now, here x component is there. Here also x component is there. Here y. Here y. Here z component. Here z component. So this side one vector is there. This side also one vector is there. In mathematics subject, this vector is equal to this vector means this side x component and this side x component should be equal. This side y component and this side y component should be equal. Similarly, z component should be equal. So compare both sides. Compare both sides. If you compare both sides, here dou square exs divided by dou z square is equal to gamma square exs. Okay, here this is equation number 5. Similarly, compare y components. Dou square eys divided by dou z square is equal to gamma square eys. This is equation number 6. Similarly, compare z components. So dou square ezs divided by dou z square. Dou square ezs divided by dou z square is equal to gamma square ezs. So this is equation number 7. Now, if you see carefully, this equation is looking different. Z component Ez divided by Z square is little different. But here x component by z square, y component by z square, these two are different type. This is different type. Here z component by z square is there. Now we will do some derivation. Na? Then these components will not be there. We will see that. Okay, students. So if we solve this equation, we get electric field equation. If we solve this equation, we get electric field x component. If we solve this equation, we get electric field y component. So these two are similar equations. No need to solve both of them. Solving this equation is sufficient, student. Okay. Now we are going to solve this one, equation number 5. Anyway, before solving this, I will explain you what is the meaning of transverse electromagnetic wave, TEM wave. I will explain that. So we will stop this discussion and we will do one simple mathematics. We will show that this becomes 0, and again after showing that I will write the definition of TEM mode. After that again we will continue the solution of this one. Okay. So now you know this equation. Divergence of ES bar is equal to 0. This we have derived divergence of D is equal to rho V for linear medium D is equal to epsilon E. For charge free region this is 0, and for homogeneous medium epsilon is constant, it comes out. Then divergence of E is equal to 0. So divergence of E 0. In phasor domain it is written like this. Okay. Now here ES bar is equal to, it has x component in phasor domain, y component in phasor domain, z component in phasor domain. So let us say this is the equation. We got equation 5, 6, 7. This is 8. This is 9. So put 9 in 10. Then divergence of electric field formula in a rectangular system. You know, dou Exs by dou x. Actually, student, divergence of E bar in rectangular system is this one. Dou Ex by dou x, dou Ey divided by dou y, dou Ez divided by dou z is equal to 0. In phasor domain, electric field x component in phasor domain, y component in phasor domain, z component in phasor domain. Now, this is general equation, but we are doing derivations for wave traveling in z direction. So here, for wave traveling in z direction, electric field Exs comma Eys comma Ezs are functions of z only. So electric field can have any components. They can be present, they may not be present, it doesn't matter. But if they are present, electric field xyz components are present, then they should be functions of z only. So then this becomes, if electric field x component is a function of z, then partial differentiation with the x becomes 0. If electric field y component is a function of z, then partial differentiation with y also become 0. These two become 0. Then this may be present. So that equation becomes 0 plus 0 plus dou E Zs divided by dou Z is equal to 0. That means one time differentiation become 0. Even if you do 2 times differentiation, so dou square Ez divided by dou z square is equal to 0. So this is put equation 9 in 8 actually. Okay. So now this becomes equation number 10. So dear students, put equation 10 in, there 5, 6, 7 is there. In 7, then 0 is equal to gamma square EZS. From this EZS is equal to 0. Here you got one conclusion. If you see carefully, I took del square ES is equal to gamma square ES at the beginning. Then I used this equation called divergence of ES is equal to 0. Then for wave traveling in z direction, EZS 0 I got after doing derivations. That means electric field can have now x component and y component only, because we did not get 0. So electric field can have x component and y component. For wave traveling in z direction, electric field z component has become 0, but electric field x and y components can be present. Actually they are present only. Similar to this, we have an equation del square Hs is equal to gamma square Hs, and similar to this we have an equation divergence of Hs is equal to 0. I told you this one, divergence of B 0, divergence of mu into H bar is equal to 0, mu comes this side, so divergence of H bar is equal to 0, so divergence of H bar becomes 0, this one. So this equation similar to them. Again you take for wave traveling in z direction, we get exact conclusion Hzs is equal to 0, and dou square Hzs by dou z square also become 0. Then magnetic field x component and magnetic field y component can be present, dear students. So magnetic field x and y components can be present. Now here we get the definition of transverse electromagnetic wave. So what is the meaning of transverse? Means 90 degrees. Electro, that means electric field. Electric field for wave traveling in z direction, electric field has x comma y components. So both x comma y components are perpendicular, that means 90 degrees, that means transverse to the wave propagation direction. So here I will take, this is wave propagation direction, z direction. Then electric field will have only x component, this one, and y component, this one. So for wave traveling in z direction, the electric field can have x comma y components only. Both x and y components are 90 degrees to the wave propagation direction, this one. So that is why it is called a transverse electric field. Similarly, for wave traveling in z direction, magnetic field also has x component and y component. So both magnetic field x and y components are 90 degrees to the wave propagation direction. 90 degrees means transverse. So 90 degrees has different names: transverse, normal, perpendicular. So many names are there. So that is called transverse magnetic. So both the electric field and magnetic field are 90 degrees to the wave propagation direction. That is why it is called transverse electromagnetic wave. TEM wave it is called as. So, dear student, TEM wave definition: if wave travels in z direction, then for TEM wave EZ0 HZ0, then automatically wave traveling in z direction, then electric field z component, magnetic field z component 0, then automatically electric field will have x comma y components, magnetic field will have x comma y components. So both electric field and magnetic field are transverse to the wave propagation direction. So it is called TEM wave. Now, you students, for objective question, you have to remember this one. How you remember this? Very simple. For wave traveling in z direction, z by z square equation becomes 0. That is also objective question, student. Now, whatever I have explained here, I will write here in the box. Box में लिखूंगा मैं, right? So I am writing here for wave traveling in z direction, dou square EZS divided by dou z square 0, this one only. And from this we get EZS 0. And similarly, dou square HZS divided by dou z square is equal to 0. Very simple to understand. Z by Z square. Z component by Z square, comma, HZS becomes 0. Okay. So this you have to put in the box. This is objective question, student. They will ask like this: for wave traveling in z direction, this is option A, this is option B, this is option C, this is option D. Which of the following correct? All are correct. Multi-select question, that is. Now, for wave traveling in z direction, both electric field and electric field, that means I will write equation here as only x comma y component. Anyway, z component has become 0. Both electric field and magnetic field, I will write equation Hs bar is equal to Hxs Ax Hys Ay. Both electric field and magnetic field can have x comma y components. For wave traveling in z direction, both the electric field and magnetic field can have x comma y components. These components are transverse means 90 degree, student. Transverse to the wave propagation direction. That means in this case that is z direction. So wave propagation direction here, that is z direction. So this electromagnetic wave, EM wave, electromagnetic wave is called as transverse electromagnetic, that means TEM, transverse electromagnetic wave it is called as. Okay, so this, you see this, actually I wrote this elaborately, but in simple way you can write this. For wave traveling in z direction, both electric field and magnetic field will have transverse components. That is why it is called transverse electromagnetic wave equation. Very simple statement. Once again I am telling, for wave traveling in z direction, Both electric field and magnetic field will have transverse components. So that is why it is called as transverse electromagnetic wave. So in objective questions they ask for TEM wave, for wave traveling in z direction, EZS 0, HZS 0, you have to remember that one. Now I was discussing here. I told you I will stop the discussion here. I stopped the discussion here, and there I have proved this equation is not present for wave traveling in z direction. Now both of them will be there. If you solve this one, you get equation of electric field x component. If you solve this one, equation of electric field y component, then both are similar equations. No need to solve both of them. If you solve this equation, that is more than enough. Now let us take once again equation number 5. So equation 5 is dou square Exs divided by dou z square is equal to gamma square Exs. That is equation number 5, students. Now solution d square Exs, this side you get minus gamma square Exs 0 here where d is equal to dou by dou z actually. Student, this is a differential equation. I won't give much importance to the solution. I will give importance to the meaning of that one. What solution we get, we have to analyze that one. So now d square minus gamma square Exs is equal to 0. Then roots are d square minus gamma square 0. That means d minus gamma into d plus gamma is equal to 0. So first root is you say plus gamma, second root is minus gamma. Then solution, let us say this equation number where you are getting 9, 10, let us say equation number 11. So solution of equation 11 is solution of equation 11 is, it is like this. This actually bottom side whatever is there, that is called z, that is independent variable. This is called dependent variable. So dependent variable is equal to, here for first root you put constant 1 exponential, this root is gamma multiplied with bottom variable, that is independent variable z, plus for second root constant 2 into e power, this is minus gamma into z. Now student, here I want to explain something. You listen carefully. Let us say this is equation number 12. For example, cos of omega t minus beta z came. I told you omega t is a time phase. Inside the cos whatever is there, that is called phase. Omega t is time phase, beta z is distance phase, omega t minus beta z is total phase. Now you take a total phase is equal to 0, then beta z is equal to omega t, then from this z is equal to omega t by beta. Here omega is 2 pi f, that is positive, t is positive, beta is positive, so z becomes positive. That means z positive means this is the equation of wave traveling in positive z direction. So this is the equation of wave traveling in positive z direction. You remember, in the equation in front of distance called z, minus is there, then here you get plus, so that is the wave traveling in z direction. Now here in front of the distance minus is there, this is the equation for wave traveling in plus z direction. I will show you from this one, you will get this type of equation. Similarly, beside the distance plus is there, then from this I will get this equation cos of omega t, cos of omega t plus beta z I will get. So you make this omega t plus beta z 0. From this z is equal to minus omega t by beta you will get. Here omega positive, 2 pi f, frequency is positive, time positive, beta is constant, that is also positive. So this is negative. That means z negative means this is the equation of wave traveling in minus z direction. Minus z direction. So you remember this one. Inside cos signal plus distance is there, or in exponential also plus distance is there, then they are the wave traveling in minus z direction. Similarly, in the exponential minus distance is there, or otherwise inside cos signal minus distance is there, then they are wave traveling in plus z direction. You have to remember that. Gradually, I will be explaining one by one. So many points I will explain. Then you will understand this um, uniform plane wave topic. So you can't learn all the things at a single place. So gradually you have to learn. हर चीज है, पूरा चीज एक ही जगह में आप सीख नहीं सकता, थोड़ा 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 सीखते रहना है आप लोग. So dear students, in the exponential positive distance, inside cos also positive distance is there, then you get that is the equation of wave traveling in negative z direction, because z is getting negative. Similarly, in exponential minus z is there, and inside cos signal minus z is there, then that is the equation for wave traveling in plus z direction. Now here, why wave travels in plus z direction, in minus z direction, I will explain now. For example, this one is z axis. Okay. Here, this is here na, this is air medium. And for example, here you are getting wood material. That means here above this you are getting wood material. So this is all z direction here. Z direction. Now this is wood material. For example, here in the air medium, one antenna is there like this. This antenna is sending the electromagnetic wave in z direction. So if this sends electromagnetic wave in z direction, from this antenna electromagnetic wave here na, radio mirchi signal is connected, then it generates a EM wave. Then let us say EM wave is going like this. EM wave is going like this. Now this EM wave is going in which direction? Z direction. This EM wave is called as a wave traveling in plus z direction. It is wave traveling in plus z direction you will call. Now it is air medium. Antenna is in air medium. Now this EM wave is going like this in plus z direction. That is also called as incident wave. So now when it enters the wood medium, inside the wood epsilon mu is there. So inside the wood also EM wave travels. Now wherever epsilon is there, their electric field is transferred. Wherever mu is present, their magnetic field is transferred. That is why even then we are inside the room, we get the signal, because electromagnetic wave travels in the air, then it enters into the cement wall also, it crosses the cement wall also. Even we are inside the room, we get the signal if strength of that is more, because inside the cement wall also epsilon and mu are present. So in this wood material, this EM wave goes and some amount of EM wave enters, but some amount of EM wave is reflected. So whenever the impedance of this medium 1, we have discussed na, in boundary conditions, this is called medium 1, this is called medium 2. If impedance of this, we will study impedance. We have not studied till now. अभी तक नहीं पढ़ा impedance, पढ़ने वाला है impedance. इसका भी इम्पिडेंस रहता है, उसका भी इम्पिडेंस रहता है. So if impedance of medium 2 and medium 1 are not matching, then some amount of signal is transferred into the medium 2 and some amount of signal is reflected. So now here this EM wave little bit transmitted to medium 2 and little bit reflected here. So this is called now wave traveling in minus z direction. This one, reflected one, is called wave traveling in minus z direction. That is also called as reflected wave. And this one is called wave traveling in plus z direction, or otherwise incident wave. Incident wave means forward wave. आगे जाने वाला है. So here in general, this reflected wave value is very small. You can neglect that. But if this is a conductor medium, then total signal is reflected. Then in that case, you cannot neglect the reflected signal. We will study that also. You don't worry about that. Now, here this mathematics gave wave traveling. This mathematics gave electric field equation for wave traveling in plus z direction and electric field equation for wave traveling in minus z direction. It has given. It is our responsibility to understand this one. Okay, students. Now, wherever, dear students, for example, this is medium 2, this is medium 1. EM wave is traveling here, and then it entered into the medium 2. Now, some amount of EM wave entered here, some amount of EM wave reflected here. So this is called Z is equal to 0. At Z is equal to 0, this incident wave electric field has EI0 value. For example, let us assume that the incident EM wave electric field value is 5 volts. We will call that 5 volts as a EI0. 0 means at Z is equal to 0 distance. E means electric field value. I means incident wave. So that is called initial value. Z is equal to 0 means initial. So initial electric field of incident wave, that is called. Similarly, out of 5 volts, let us say 1 volt is reflected, then that is called initial value. Initial means 0. It is also called naught. So initial value of initial electric field of reflected wave, that is called ER0. So dear students, EI0, E means electric field, I means incident wave, 0 means at Z is equal to 0. So initial electric field EI0 is called initial electric field of incident wave. ER0 means initial electric field of reflected wave. So for example 1 volt, like that some values are present. So now assume only this is there. Then EXS, it is a function of Z here. Electric field X component in phasor domain is a function of Z, means that means wave may be traveling in plus minus Z direction. If you take this, that is wave is traveling in plus Z direction. If you take this, that is wave is traveling in minus Z direction. So assume that only this is present, e power minus gamma Z. Now you substitute Z is equal to 0. So EXS Z is equal to 0. Then C2 e power 0. This is 1. Now this constant 2 is nothing but electric field value only. So that is electric field at Z is equal to 0. That is called that is electric field value whenever Z is equal to 0. Then this is incident wave, or otherwise wave traveling in plus Z direction. So for incident wave, I is kept. So this C2 should be electric field value only. So that is called as EI0. So that may be 5 volt, 10 volt, 20 volt, whatever value you may send here from the antenna, that much value will be there for that. that will be given in the question. The person who is sending EM wave, for that person, that value is known, that is written on the paper, who will be studying that one. Anyway, similarly, you take only this equation, EXS is equal to C1 into e power gamma z. Once again, it is a function of z. Now substitute z is equal to 0, then C1 into e power gamma into 0. So this is 1 actually. So C1 is nothing but electric field only. Whenever z is equal to 0, then that is for reflected wave. So ER0 it is written. Don't confuse, this is gamma. This is a reflected wave. So this is called initial electric field of reflected wave. Now, if we write that, this is only rough work, student. I explained you. Okay. Now I am writing here. If EI0 is, or otherwise, okay, no problem. If EI0 is initial means at z is equal to 0. Initial electric, here z0 means initial, E means electric field, for I means incident wave, is initial electric field of incident wave, comma, ER0 is initial electric field of a reflected wave, then equation 12 becomes EXS is equal to, this is reflected wave, so ER0 e power gamma z plus EI0 e power minus gamma z. My dear students, this derivation is useless, not useful, but this solution what you got, you have to remember that that is useful, and we will discuss that now. This is useful. I am writing here. What is this? Electric field equation. Electric field equation changes exponentially here. So this is a electric field equation of reflected wave, or otherwise electric field equation of wave traveling in minus z direction. I told you in an exponential plus z is there, means that is the wave traveling in minus z direction. Now what is this, dear students? This is electric field equation of incident wave or electric field equation of wave traveling in plus z direction. So again and again, no need to discuss. In the next chapter also, here we get V is equal to VR0 e power gamma z, Vi0 e power minus gamma z. Then simply I will not explain there. Simply I will be writing voltage equation of reflected wave or wave traveling in minus z direction, because we have to discuss new things. Again, same thing we should not discuss. Okay, students. So this one you have to remember. This equation I am putting in the box. This name also you have to remember. Now after going home, If you are reading this means you do not know how to prepare for competitive exams. You know how to waste your time. That is why I am telling, one time you listen, you forget about that, then what is there here, you have to remember that. Then you will not be wasting your time. Then you will know how to prepare for a competitive exam. Definitely you will be a top ranker. Okay. So unnecessary derivations, no use at all. But here we are deriving for continuity purpose. So ultimately, these results are important, students. Okay. Now, okay. Now, actually, we will be discussing by taking this incident wave. For example, student, I told you that you are inside your room with your mobile phone. From Airtel station, you are getting signal means the forward signal strength is very high. That is why you are getting the signal, but the reflected signal strength is very less. You can neglect that one. So that is why let the medium impedances are matched, then only wave traveling in z direction only present, we will take that and we will analyze that one. But if the reflected signal strength is very high, then you cannot neglect that one also. That case also we will discuss later on, don't worry. So let medium impedances are matched, then there exists incident wave. For this case, Exs is a function of z is equal to ei0 into e power minus gamma z. It is very easy to remember this equation, student. Don't block your mind. दिमाग को बंद मत करिए आप लोग. Simply ये equation है some constant into exponential, वही है solution. ज़्यादा परेशान होने की जरूरत नहीं है. आप लोग ये डेरिवेशन के ऊपर बढ़िया से कंसंट्रेशन करेंगे ना, इधर क्या आया हुआ है उसके ऊपर ध्यान नहीं देंगे, वही इंपॉर्टेंट है एग्जाम के लिए. थोड़ा सा जो बॉक्स में है सिर्फ उसको ध्यान देते रहो आप लोग. सो इन दिस इक्वेशन ei0 e power minus gamma z, here gamma is alpha plus j beta into z. This is electric field equation of incident wave in phasor domain. Anyway, I will write here ei0 is initial electric field of incident wave. Either wave means EM wave. Wave means always EM wave, electromagnetic wave. No need to write every time electromagnetic wave, no need to write. Wave means electromagnetic wave here. Similarly, ER0 is initial electric field of reflected wave. You put them in the box also, because in examination, in questions they give, so you must know what is that. Now, this is in phasor domain. Electric field equation in time domain is, this is phasor domain Exs. No need to write every time it is a function of z, no need to write. Simply Exs you write. Multiply with e power j omega t. Then you take real part. Then you get electric field x component in time domain. That is why I am not writing s. Then that will be a function of z. Already it is a function of z. And in time domain it will be a function of time also. So you see the notation. Notation मतलब symbol. ये symbol भी observe करो. E मतलब electric field. X मतलब x component. It is a function of, for wave traveling in z direction, z comes. In time domain, time also comes. So this is the format of writing the electric field equation. Now this is equal to Re. Excess is this one. E I0 e power minus alpha z e power minus j beta z, then multiplied with e power j omega t. So this becomes here EA0 is not a complex number, e power minus alpha z is not a complex number, so they can come out. Now real part of e power j, j is common in the exponential, so omega t minus beta z is there. So dear students, now the equation becomes EA0 e power minus alpha z. This is written as cos plus j sine, but real part means cos of omega t minus beta z you get. So I am writing that equation that side. That is the time domain electric field equation. Okay. Now that equation electric field x component function of z comma t, that means for wave traveling in z direction it is a function of z, and in time domain is a function of t, is equal to a0 e power minus alpha z. If you take real part, you get cos of omega t minus beta z. So this equation you have to remember, dear students. Now I am putting this in the box. If you want a vector format, then E bar is equal to electric field x component Ax cap. That means this is electric field x component. Beside that you put Ax cap, that becomes a vector actually. If both components are there, then Ex Ax plus Ey Ay, like that you will write. Now one by one we will see. In network theory also 5 cos omega t is there, that 5 is called magnitude of the voltage, or otherwise the amplitude of the voltage you will call. So beside cos you have this one. This is called amplitude, or otherwise magnitude of electric field at z distance. If you put z0, this is 1, then this is called amplitude, or otherwise magnitude. That is also called initial value of electric field at z is equal to 0. This terminology you have to remember to solve the questions. They give initial electric field is 5 volts in the 5 volt per meter in the question. That means they have given EA0. You must be able to write that. So that is what you have to learn here. So here at z is equal to 0, or otherwise I will write like this. EA0 is initial. Already I wrote there, but here I am writing initial electric field of incident wave. Now at z distance, amplitude, or otherwise magnitude of electric field is EI0 e power minus alpha z. This you have to remember, because they will ask you at 10 meters distance what is the magnitude of the electric field. Then you have to put z is equal to 10. You have to calculate alpha, and they give EA0. So this is the value. At z distance, amplitude or otherwise magnitude of electric field is EA0 into e power minus alpha z. Students, for any medium, if alpha is 0, then electric field is EA0. Then even if z changes, then magnitude does not change. That is called lossless medium. If alpha 0, then amplitude is ei 0 and that is constant, then wave travels in z direction, then this value does not change. That means if electric field value does not decrease, then loss is not there. So if alpha 0, then amplitude is a 0, that is constant. So there is no loss. That is called lossless medium. If alpha is not 0, we will discuss all those things. Then amplitude ei 0 into e power minus alpha z decreases when wave travels in z direction. Decreases or otherwise decay, decay, decay means decrease. Attenuate means decrease. Attenuate, decay, decrease, all are same, they are synonyms. So because of alpha, there is a decrease in the electric field whenever wave travels. Wave traveling means at z is equal to 0, wave starts its journey. वो शुरू करता है उसका journey. Then when z 0, then EA 0 is the value. When z is equal to 10 meter, then this value decreases. So that is called attenuation. Attenuation means decrease. Why it is decreasing? Because of alpha term. For any medium alpha is present, then it is constant also. That is called attenuation constant, because that alpha is responsible for attenuation in the electric field, decrease in the electric field. That is why it is called attenuation constant. So if alpha not 0, then amplitude decreases when wave travels in z direction. So alpha is called as a attenuation constant. Here no need to put this in the box. There already in previous discussion I wrote alpha is attenuation constant measured in Napa per meter. Actually last terms no exponential term no e power 1 means 1 Napa. E power plus 1 means 1 Napa increase. It is defined like that. E means 1 Napa student. E power plus 1 means 1 Napa increase. E power minus 1 means 1 Napa decrease. That is, it is termed like that. So students, now you see this one. Omega t is called time phase. I am putting that in the box means you have to remember that. That means whenever time changes, this phase is going to change. And similarly, beta z is called distance phase. Now omega t minus beta z. Omega t minus beta z is called total phase. I told you inside cos, inside sine, inside tan, whatever term is there, that is called phase term. So this is called total phase, dear students. Now, what is the meaning of traveling wave? For example, you are in the bus. If you are in the bus, then your bus moves. आप गाड़ी में बैठा हुआ है, अब गाड़ी चल रहा है. Then if anybody calls you, then you will say you are in the traveling, you are in the journey. आप लोग बोलता है हम traveling कर रहा है बोलता है. So if you are in the bus, that means you will say you are in traveling. What is the meaning of traveling in the bus? When you are in the bus, time also changes. Then bus is moving, distance also changes. That means that is a function of distance and time. That is called traveling. So here this equation is a function of time as well as distance, that is called traveling wave. So if any equation in terms of distance and time, that is called traveling wave. So dear students, whenever wave is traveling, it will have some velocity, it will have some wavelength. We will talk of those equations also here. Now this is called total phase. Okay, now I will take the total phase constant. If total phase is constant, then I will differentiate that, then I will get the equation for constant phase velocity. Constant phase velocity. Slowly I am explaining one by one. You listen carefully and learn them. So if total phase is constant, that means omega t minus beta z is equal to constant. Now you differentiate with respect to time t, then it becomes omega into d by dt of this is 1 minus beta into dz by dt. So d by dt of constant. What is d by dt of constant? 0. So now from this dz by dt is equal to omega by beta. If you see the units, this is radian per second divided by radian per meter. You get meter per second. Meter per second is nothing but velocity. You can see here also dz, distance. Distance means meter. dt, time. Time means second. Meter per second. What is meter per second? Velocity. How you got that velocity? By taking phase constant. That is why it is called constant phase velocity. So this is the definition. V means velocity, suffix p means constant phase. The definition is omega by beta. How you got this? By making phase constant. By making total phase constant, you got that. Then what is the meaning of that? What is the, when wave travels, what is the velocity of constant phase point in the wave? Then that is omega by beta. For example, when wave traveling, then electric field equation is this one. For example, if you take this phase point for traveling wave, after some time this goes from here to here, after some time it goes from here to here. So that constant phase point is traveling with which velocity? Answer, with this velocity. So that is called constant phase velocity. So here student, this is a unit is a meter per second, and where Vp is constant phase velocity. Simply in the books they say phase velocity. They don't say constant phase velocity. So simply they say phase velocity. Okay, this one. And definition you got here. Phase velocity. Just I am reviewing what you have remembered till now. For wave traveling in z direction, EZS and HZS both become 0. That is why it is called transverse electromagnetic wave. Then after that, electric field solution in phasor domain for wave traveling in plus z direction is EA0 into e power minus gamma z in phasor domain, and in time domain that is the equation. And after that we have seen what is omega t, and that is time phase, beta z is distance phase, omega t minus beta z is total phase, and then constant phase velocity we have seen. Then already you know the definition of wavelength, already I explained you. So beta z, I will write like this: when z is equal to 0, then distance phase beta z becomes 0, because I have put z is equal to 0. When wave travels for z is equal to lambda meter distance, then if distance phase beta z becomes 2 pi radian, if distance phase, that is beta z, that means you have to substitute z is equal to lambda, then this distance phase becomes 2 pi radian, then lambda is called as distance period, or this is also called as wavelength. That means when this lambda is repetition of distance, whenever distance repeats for lambda meters distance, then distance phase also repeats for 2 pi radians. So that is the definition of the uh, lambda. So that means beta lambda is equal to 2 pi. So already I wrote this. Then beta is equal to 2 pi by lambda. So this 2 pi means radian, and lambda is meter. So the unit is radian per meter. So this, you may remember this or this, then automatically, for example, if you remember this one, beta is equal to 2 pi by lambda, then lambda you want 2 pi by beta. Both equations are required to solve the question. Sometimes they give lambda, then beta is nothing but 2 pi by lambda. Sometimes they give beta, if you want lambda, lambda is equal to 2 pi by beta. You remember this equation, there is more than enough, where beta is the phase shift constant, lambda is wavelength. So dear student, why beta is called phase shift constant? You get answer here. Whenever beta is 0, then even if distance changes, if beta is 0, then even if distance changes, the distance phase is not there. If beta value is there, that means beta is not 0 for any medium. For example, let us say 10, beta is 10, then 10 into z. Then if wave travels, z keep changing, then this distance phase also changes. That is why this beta is responsible for change of the phase. That is why that is called phase shift constant. Shift means change. So that beta is responsible to change in the phase, or otherwise shift in the phase whenever wave travels. So that is why that is called phase shift constant. So beta is a phase shift constant measured in radian per meter. Beta is, already I wrote there, na student, at one place I wrote there, that is attenuation constant alpha. This is beta is phase shift constant. Then gamma is a combination of alpha and beta. This alpha tells you regarding attenuation, this beta tells you regarding phase shift. So whenever attenuation and phase shift both are known, then wave propagation characteristics are known. That is why this gamma is called as a propagation constant. This gamma has a propagation characteristics called attenuation as well as phase shift. That is why it is called as propagation constant. The unit is 1 by meter. So Nepper per meter means it represents the loss term, LOSS loss. Radian per meter means that represents a phase shift constant. 1 by meter means that represents gamma, propagation constant. Okay. Now, dear students, you know the equation of electric field. You know the equation of electric field of electromagnetic wave in phasor domain as well as time domain. So you know that in time varying fields, time varying electric field generates time varying magnetic field. Time varying magnetic field generates time varying electric field. In network theory, if you apply voltage to a network, then that generates current. For example, if you apply current, then that generates voltage. There in network theory, voltage is converted to current, current is converted to voltage because of impedance present in the network. Because of impedance present in the network. That is why V by I is equal to impedance. V by I is equal to impedance. What is the meaning of that? Because of impedance, students, V by I is equal to impedance. What is the meaning of this? Because of impedance present in the network, voltage is converted to current, current is converted to voltage. That is the meaning. Similarly, in electromagnetic theory also, electric field by magnetic field is equal to impedance we get. What is the meaning of this? Because of the impedance of the medium, electric field is converted to magnetic field. Magnetic field is converted to electric field. That is the meaning of that one. Now we will see the equation of this one. So here I am writing one heading. You observe that heading carefully. The heading is electric field or otherwise I will write like this. Electric field X component is there here. Then which component of magnetic field is generated? I will write like that. H bar due to EXS only. What is the meaning? I am asking question here. What is that question? If electric field has X component, then which component of magnetic field is generated? That is the question. Now, what will be the answer? The answer is you take the Maxwell equation and do the derivation and then you get the answer. So, dear students, H bar due to electric field X component, we want to do the derivation. So, which component of H bar is produced due to electric field X component? So, now let us do the derivation. H bar due to EXS only. That means magnetic field produced due to electric field X component only. Why I wrote only? If electric field X component only present, then which component of magnetic field is generated? The answer is given by Maxwell equation. Now let us see what is that. I am writing here some rough work you see. We have seen two equations, students. Del cross E S is equal to minus j omega mu into Hs bar. Similarly, del cross Hs is equal to sigma plus j omega epsilon Es bar. We have seen two equations. In these equations, if electric field is known, you substitute that electric field here then you get because of this electric field component, which component of magnetic field is produced, that is given by this equation. Similarly, if you know the magnetic field equation, you substitute that magnetic field here, then you get how much electric field is produced. You get that you get from this equation. Once again, I am repeating. If you know electric field, you substitute that electric field here. Then because of that electric field, how much magnetic field and which component of magnetic field is produced, that is given by this equation. Second statement. If you know magnetic field, you substitute that here. Then how much electric field is produced, which component of electric field is produced, that is given by this equation. Now we know electric field equation in phasor domain Exs. Then you substitute that one here. Then you will get which component of magnetic field is produced, how much magnetic field is produced, that is given by this equation. So first I will write Exs. So now here electric field phasor component is equal to electric field only we are taking only x component is present, so that is nothing but Exs Ax. What was Exs? Ei0 e power minus gamma z. Like this I will put bracket. This is nothing but this one only. Okay. Now because of electric field x component, which component of magnetic field is produced, how much magnetic field is produced, we want to know. So that is why you take equation del cross Es bar is equal to minus of j omega mu Hs bar. Now in rectangular system, del cross Es is equal to unit vectors Ax cap, Ay cap, Az cap, then dou by dou x, dou by dou y, dou by dou z, that means partial differentiation. Then electric field x component only is present, that electric field x component is Ei0 e power minus gamma z. Then electric field y component 0, z component 0. Why electric field y component 0? Because we are deriving magnetic field component due to electric field x component only. So that is minus j omega mu into Hs bar. Now here you expand this determinant Ax, leave this one, dou by dou y of this, dou by dou z of this 0. Minus Ay, leave this one, dou by dou x of this 0 minus dou by dou z of this one, dou by dou z of this one. You get A0 dou by dou z of e power minus gamma z is e power minus gamma z into minus gamma. Next plus Az cap, this one, dou by dou x of this 0 minus dou by dou y of this one. There is no y component here, so partial differentiation with respect to y becomes 0. That is equal to minus j omega mu Hs bar. Now here minus becomes plus, and here minus is there. This minus also becomes plus, and ultimately I am writing this as a Exs again. Exs means Ei0 e power minus gamma z. This is Exs. So dear students, this is Exs, this one, and gamma, then Ay, minus into minus plus, this minus and this minus plus. I am writing this as the Exs. This is gamma, this is Ay, is equal to j omega mu into Hs bar means it can have x component, it can have y component, it can have z component also. We do not know which component is present. That is why I wrote all. Now if you compare this side, then you will come to know which component of magnetic field is present. So this side direction is there means vector, this side directions are there means vector. Two vectors are equal means this side component should be 0. Here x component 0, that is why Hxs becomes 0. Here z component is 0, That is why HZS becomes 0. Here only y component is there. Here only y component present. So you compare both sides. Compare both sides. Then you get EXS into gamma is equal to this side j omega mu into here y component na this one, here also y component, here y component is j omega mu into hys, so hys, then other component 0. From this we got one interesting answer. What is that answer? Electric field x component generates magnetic field y component. That is why I told you x and y are 90 degrees. That is why I told you electric field is always perpendicular to the magnetic field. For example, electric field x component means in this direction, x direction. Then magnetic field is generated that will be in y direction. Then electric and magnetic field will be perpendicular to them, perpendicular to each other. So here now EXS divided by HYS is equal to j omega mu divided by gamma. So j omega mu, what is gamma? Root of j omega mu sigma plus j omega epsilon. So j omega mu cancel. So ultimately you get root of j omega mu divided by sigma plus j omega epsilon, student. Now if you observe carefully, what is this? Volt per meter. What is this? Ampere per meter. Per meter cancel. Volt by ampere. Network theory, what is volt by ampere? V by I, that is impedance. That means it is ohm. Ohm means impedance. And here this impedance is coming because of epsilon, mu and sigma. These epsilon, mu, sigma are called as medium parameters. They are also called as intrinsic parameters. Intrinsic means natural. Wherever medium is there, naturally this epsilon, mu, sigma are present because of these natural parameters. Naturally present there. For medium, no, these parameters naturally exist. So these are called natural parameters, or otherwise intrinsic parameters, or otherwise medium parameters. So because of these intrinsic parameters called epsilon, mu, sigma, you are getting impedance that is called intrinsic impedance. Intrinsic impedance means that impedance is naturally present for that medium. We are not creating that impedance. Already Bhagavan, God has created that medium. For that medium, these parameters are present. That impedance is present. Already that is inbuilt. That is why it is called intrinsic impedance. That is given one symbol called eta. So this symbol is eta. You write n, then pull that one. So this is eta, eta pronunciation. So symbol is this eta. So intrinsic impedance symbol. So in network theory, Z symbol is used for impedance. No, here eta is used. eta. So dear students, now here we got one important conclusion that electric field X component in phasor domain divided by magnetic field Y component in phasor domain is equal to j omega mu sigma plus j omega epsilon, and the root, the units of this is ohm, that is called as eta. Now this is a complex number by complex number is complex number, root of complex is complex, that complex has real part and imaginary part. So this is called as eta real plus j eta imaginary part. This is complex. So every complex number can be written as magnitude modulus of that and e power j angle of that theta eta. So this is also called as eta magnitude, and theta means angle of eta. I am writing all the things because in different textbooks they express in different ways. In some textbooks they write eta real and eta imaginary. Actually, if there is a complex number, then you will write magnitude and angle tan inverse of b by a. So this is called magnitude, this is called angle. So magnitude is called as modulus and e power j. Theta means angle, that angle for intrinsic impedance. That is why suffix eta is written. So this modulus of eta is called eta magnitude. Like this they represent. So anyway, so dear students, I am putting this in the box. This one. You have to remember this one. So this is a complex number, and that eta is equal to eta magnitude and e power j. Theta means angle, angle of intrinsic impedance, that is. Okay. Now what is the meaning of this? You see, already I told you, once again I am telling. Whenever EM wave travels in the medium, this medium, for example air medium, has epsilon and mu. Because of that epsilon and mu, impedance is present, that is called eta. That impedance converts electric field x component into magnetic field y component, magnetic field y component converted into electric field x component, so that EM wave travels in forward direction, आगे बढ़ता है. सो ये इक्वेशन याद करने के बाद आप लोगों को अगर मैथमेटिक्स से एटा मैग्नीट्यूड एंड एंगल चाहिए तो आसान से आप लोग कैलकुलेशन कर सकता है. मैं इधर करता हूं, देख लीजिए आप लोग. सो दैट impedance is equal to j omega mu sigma plus j omega epsilon under root. This is equal to j omega mu divided by j omega epsilon. I am taking common from this j omega epsilon. Then it becomes sigma by j omega epsilon plus 1. And okay, I will take root here. So this j omega cancel. Ultimately you get j omega cancel. You get root mu by epsilon divided by this one is 1. 1 by j is minus j sigma by omega epsilon. Root is there, so whole power half. Like this, dear students, a plus or minus jb is equal to root of a square plus b square e power plus or minus j tan inverse of b by a. Similar to this, I can write 1 minus j sigma by omega epsilon like this, root of 1 square plus sigma by omega epsilon whole square. Now e power minus plus is there means plus, minus is there means minus, minus is there, so minus j tan inverse of b by a. B means imaginary, a means real, so sigma by omega epsilon. So this one 1 minus j sigma by omega epsilon is written like this. Whole power half is there, so whole power half is there, that is nothing but root mu by epsilon. This one is 1 plus sigma by omega epsilon whole square, root is there, then e power minus j tan inverse of sigma by omega epsilon. This is this one, whole power half is there. Now shall I write here or here? Okay, I will write here. That implies eta is equal to, I will separate the magnitude, root mu by epsilon divided by 1 plus sigma by omega epsilon whole square. This one 1 plus sigma by omega epsilon whole square. Here whole power half is there, here whole power half is there, so that becomes power 1 by 4. Now if whole power half comes here, then in the exponential it becomes half. So e power minus j tan inverse of sigma by omega epsilon by 2 comes. If it goes to numerator, minus j becomes plus j. So e power j tan inverse of sigma by omega epsilon divided by 2. So in the exponential, e power j tan inverse of sigma by omega epsilon by 2 is there. Now this is eta is equal to eta magnitude and e power j. This is theta means angle of intrinsic impedance, that is called theta eta. So dear students, now eta magnitude is this one ready-made equation, theta eta is this one, but I suggest you to remember only theta eta because that has some significance. Later on we will see that वो याद रखना है, इसका इक्वेशन याद रखने की जरूरत नहीं है. So eta magnitude is equal to root mu by epsilon divided by 1 plus sigma by omega epsilon whole square 1 by 4. I am not putting that in the box. No need to remember that. ज़्यादा फायदा नहीं है. But theta eta is equal to tan inverse of sigma by omega epsilon divided by 2. You send this to this side, then tan also that side. Now it becomes tan 2 theta eta is equal to sigma by omega epsilon. You remember this one in this form. This is very important. Later on we will see, because this becomes a last tangent tan theta. So we will see that later on. You remember this one, dear students. Actually student, in any question they give omega value, mu value, sigma value, and you substitute them, and for example after substitution you get, let us say, eta is equal to, you substitute the values and calculate with calculator, then you get, for example, 3 at an angle of 60. Then here this is eta magnitude, this is theta eta. So in that case no need to remember this eta magnitude, directly you can calculate by calculator. But why to remember this one? It has some significance. I will tell you later on. Here theta eta is called as angle of intrinsic impedance. Intrinsic impedance, or otherwise phase difference between E and H of electromagnetic wave. This you have to remember, because electric field and magnetic field differs in phase by an angle of theta eta. I will explain this also when I solve magnetic field equation. Okay, when I solve magnetic field equation, then I will explain this. So dear students, now we are going to write magnetic field equation in terms of impedance. We will write. That is why heading I kept magnetic field. But before discussing magnetic field, I discussed impedance. Now I am going to write the magnetic field equation, because we want to write the magnetic field equation in terms of impedance. That is why. So Exs divided by Hys is equal to eta. Now that eta is nothing but mod eta e power j theta eta. Okay. Now Hys is equal to send this side Exs divided by mod eta into e power j theta eta. So Exs is nothing but Ei0 e power minus gamma z divided by mod eta e power j theta eta. So that is EA0, gamma is alpha plus j beta, e power minus alpha z, e power minus j beta z, e power minus j theta eta, it comes numerator, divided by mod eta. So HYS is equal to EI0 divided by mod eta, e power minus alpha z, then e power minus of j beta z, e power minus j theta eta. Equation numbers not giving. Okay, some equation, this is some number, let it be like that. So now this is a magnetic field y component in phasor domain. Now we want in time domain. In time domain, how you get time domain? Magnetic field y component for wave traveling in z direction, function of time is equal to real part of phasor component HYS multiplied with e power j omega t. So that is nothing but real part of HYS is this one, EA0 by modulus of eta, e power minus alpha z, e power minus j beta z, e power minus j theta eta, multiply with e power j omega t. So that becomes EA0 comes out, mod eta is not a complex number, this is also not a complex number, e power minus alpha z also comes out because it is not a complex. Then real part of e power j, this is omega t minus beta z minus theta eta. Now the final equation of magnetic field in the time domain. So that is Hy of z comma t is equal to EI0 divided by modulus of eta, e power minus alpha z. Then real part means cos of omega t minus beta z and minus theta eta. This is the equation. Now EA0 divided by mod eta is named as Hi0. So e power minus alpha z cos of omega t minus beta z minus theta eta. So you have to remember this equation, and you can write this magnitude in terms of Hi0 also, or otherwise in terms of EA0 also. You can see here volt per meter by ohm. Volt by ohm is ampere, that is ampere per meter is Hi0. Here Hi0, of course, in terms of EA0, that is EA0 by mod eta is initial, that means z is equal to 0, initial magnetic field of incident wave. Initial means at z is equal to 0. So here you can see theta eta is there. So this equation also you have to remember. For example, student, electric field x component is equal to EA0 e power minus alpha z cos of omega t minus beta z minus theta eta. Some students confuse actually. This electric field x component, this magnetic field y component, the angle between x component and y component is 90 degrees. Then what is this theta eta again? Don't confuse. We are not asking the question that what is the angle between x component and y component, that 90 degrees. We are not asking that one. Then what is the discussion? Discussion is electric field has cos term. 1 minute, student. This is not there in electric field. Okay. So electric field is EA0 e power minus alpha z cos of omega t minus beta z. This is the total phase of the cause term of electric field. Now this is the total phase of the cause term of magnetic field. Now this cause term phase minus this cause term phase gives theta eta. So theta eta is called as angle of intrinsic impedance, or otherwise angle between E and H, that gives the phase difference between cause term of magnetic field and electric field. For example, here sine also may come, because the person who is sending the EM wave can transfer the energy using the cos signal also, using the sine signal also, using the combination also. It doesn't matter. So now after this, we have to discuss power flow. What is that? Power flow, Poynting vector. We have to discuss that one.